This is the review for the Chapter 3, also known as Unit 7, Test Review. Well, problem number 1 says, when looking at a graph, how can you tell how many solutions there are? With a system of linear equations, there are only 3 things that can happen. You can graph 2 linear equations, and they have one distinct solution. If they have one solution, you're going to know because the 2 graphs intersect each other. Algebraically, you will know that 2 equations intersect each other because they will have different slopes when they're in slope-intercept form. And that's the only thing they need to be different. It doesn't matter what the y-intercepts are as long as the slopes are not the same value. The second thing that can happen is you could graph a system of linear equations and the 2 lines on the graph are parallel. Well, we know from geometry that parallel lines never intersect. And if they don't intersect, how can they have a solution? Well, they don't. So we would say this is no solution. Algebraically, we would know that 2 equations result in no solution because they have the same slope and the same y-intercept. Different y-intercepts. Let's change that. Different y-intercepts. The third thing that can happen is you can have 2 equations, and when you graph them, they're the same exact line, so you only actually see one line on your graph. That is your infinitely many, I gotta spell that right, I don't even know if I spelled it right, infinitely many solutions. You're going to know that the 2 equations algebraically are infinitely many solutions because they will have the same slope and the same y-intercept, as opposed to the no solution where they had the same slope but different y-intercepts. Problem number 2 says, when solving a system of equations or inequalities, what is a solution? Well, for a system of equations, the solution is going to be the point of intersection of the 2 lines. It's going to be an ordered pair where the 2 lines intersect each other. However, if they are inequalities, the solution is not a point. The solution is going to be the region where the shadings overlap. Because in a system of inequalities, we shade each inequality. The region of the graph where both shadings overlap is where your solution will be. In problem number 3, it says a plane is heading to an airport at a path of y equals 2x minus 5, and another plane is heading to the same airport with the equation y equals negative x plus 7. What are the coordinates of the airport? Really what they want to know is, what is the point of intersection of these 2 lines? Algebraically, the easiest way to do this problem is via substitution, if you want to do it algebraically. What I would do is I would take the second equation and substitute it into the first equation in place of y. Now I have an equation that only has one variable, and I can therefore solve it in our general algebraic method. So I would subtract x from both sides. Add x to both sides. I would subtract 5 from both sides. Then I would divide by 3. And I find out that x equals 4, and then once I know what x is, I can plug it back into either of these original 2 equations in order to find y. It doesn't matter, I'm going to plug it into the second one just because I can see it on my screen. So y is equal to negative, and notice that I put the solution in parentheses. That's important because it's negative 4 plus 7, which is 3. So the point of intersection should be at 4, 3. But I'm going to check that on my graphing calculator. Remember that I can do this on my calculator by putting both equations into the y equals function and then After I've got them plugged in, I can use second trace, number 5 intersection, enter, 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 and it'll tell me the intersection is at 4,3. However, if you choose to use the graphing calculator to get your answer, which is fine, you will get the minimum amount of points available for the problem. I have been giving extra credit for students who have been utilizing algebra to solve the problem rather than your calculator. Your calculator is fine. You will lose no points for using it if you get the right answer. But I'm giving extra credit for students who are taking the extra mile to do the problem algebraically and correctly. In problem number 4, we want to solve by graphing. Now, again, you could just do this on your graphing calculator. However, for review purposes, I'm going to do this the long way to remind you of how to graph a linear equation by hand. So the first equation, y equals 2x minus 7. The y-intercept is at -7, so I'm going to go 1, 2, 3, 4, 5, 6, 7. Here's -7. And the slope is 2 over 1. So to plot more points, I'm going to go up 2 to the right 1, up 2 to the right 1. And I'm going to do that a couple of times just so I have a nice line here. The second equation has a y-intercept at 4. Here's 4 on the y-axis. And the slope is -1/2. That means to go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. All right. Now, this is why graphing by hand is not always the best scenario. Unless I did something wrong, and I'm not convinced that I did, it appears as if the solution is approximately 1, 2, 3, 4, somewhere between 4 and 5 on the x-axis, and somewhere between 1 and 2 on the y-axis. So it's going to be a decimal answer. This is where doing the problem on the graphing calculator is better. So you'll see that my graphing calculator has told me the point of intersection is at 4.4 and 1.8. Now, graphing's not the only way of solving the system, and on the test, I actually don't care what method you use for solving. You could have solved it by graphing on the calculator and using the graphing calculator. You could have solved the problem algebraically by doing substitution, so -1/2 x plus 4 is equal to 2x minus 7. I hate fractions, so if I multiply everything by 2, it'll make the fraction go away. So I get -2x, not -2x, -1x plus 8 is equal to 4x minus 14, and then I'm going to add x to both sides. And then I'm going to add 14 to both sides. And then I'm going to divide, by 5. And I'm going to find out that x is 4.4. Who would have thought it? And then I'd plug it back in to either of the original equations. And I would find out that y is 1.8. So whichever method makes you happy is the method that I want you to use. Substitution, if you wanted to use elimination, you would have needed to put the equation in standard form, although this is not a circumstance under which I would tell you to do that because it makes the problem longer. This problem was probably best done by graphing in the graphing calculator and using the intersect function. Sometimes the setting up of the equations is just as important as being able to solve it. And this is probably the hard part for everybody, is how do you write these equations? So John has $75 and earns $10 each week. Sally has $150 and earns $4 each week. Write a system of equations to show how long it will be until they have the same amount of money. It doesn't say solve it, it just says write the system. So John's going to start with $75, and he's going to add to that $10 a week. Maybe we'll call it X. Well, that's what our total is going to be. So Y is going to represent our total amount of money. X is going to be the number of weeks. And knowing what the variables represent is extremely important. So now we can write an equation for Sally. Sally's total will be her $150 plus $4 each week. And that's the system we could use to solve to find out when they would have the same amount of money. In order to figure out when they'll have the same amount of money, I would probably do a substitution. But again, it didn't ask me to actually solve it. It just asked me which system would work. In problem number 6, it says a company sells 20 items for $84. They sell hamburgers for $5 and fries for $3. X plus y equals 20 and 5x plus 3y equals 84 is the system of equations. What do x and y stand for? Like I said, what the variables represent is extremely important. So in this particular problem, how do I figure out which variable represents what? Well, I want you to notice 5x here. Well, if I look back at the word problem, it still says that they sell hamburgers for $5. So x must be the number of hamburgers sold, because it's $5 times the number of hamburgers. Therefore, y must be the number of French fries they sell. In number 7, we want to solve the system in problem 6. You can solve it in one of 4 different ways. Method 1 is you could graph them. If you graph them and find the point of intersection, you have to put them in slope-intercept form, which means you have to solve each equation for y. So the first equation, if you solve that for y, you would subtract x. You would get y equals negative x plus 20. The second equation, you would have to subtract 5x and then divide by 3. So you're going to get negative 5/3 x plus, let's see, 28. The second equation would be negative 5/3 x plus 28. And then you would graph them and find the point of intersection. The second method you could do is substitution. I would not recommend this unless you have to. However, substitution is really extremely important for the purposes of both pre-calculus and calculus. So in order to do substitution, I might solve the first equation for y, like we did in the blue example, and then I would substitute that into the second equation in place of y. Substitution only works if you make one of the 2 variables disappear. This equation I can solve now because it only has one variable. So I would solve the equation for x, find x, and then substitute that answer back into one of the original problems to find y. The third method that I could use is elimination. This is the one you probably liked a lot in Algebra 1. In order to do elimination, I need to be able to add the 2 equations together and one of the variables eliminates. Right now, when I add them, I'm going to get 6x plus 4y equals 104. That doesn't help me any. I want one of the 2 variables to go away. So maybe I would multiply the first equation by negative 3. That's not the only way to do it. I could also multiply the first equation by negative 5. Either way, it doesn't matter which variable you make go away first. So I would get negative 3x minus 3y equals negative 60. And now I'm going to add that to 5x plus 3y equals 84. And you'll notice when I add them, the y's go away. And I find out that x is 12, and then I would plug 12 back into one of the original problems to find out that y was 8. But remember, there was a 4th method. And the 4th method of solving this is by using a matrix. The matrix that you would plug into your calculator would be 1, 1, 20, 5, 3, 84. The dimensions of the matrix are 2 by 3 because there are 2 rows and 3 columns. And you would use RREF, that's reduced row echelon form, in order to solve this problem. When you do, the solution matrix should say this, where the final column is your solution. Again, I'm not going to tell you how to solve it. You're going to choose the method that's best for you. Just make it abundantly clear on the test which method you're using. Number 8, a parent has 30 bills that are either $10 or $20. The total was $430. How many of each bill are there? In order to solve this, we're going to set up a system of equations. The first equation that we're going to write is for the total number of bills. I know that there are $10 bills and $20 bills, and when I add them together, there are 30 total bills. So X is going to be the number of $10 bills. Oops, wrong symbol. There we go. And we're going to call Y the number of $20 bills. The second equation is going to have to do with the amount of money. The amount of money is going to be found by multiplying 10 times the number of $10 bills plus 20 times the number of $20 bills, and that's going to equal $430. So now I have a system of equations that I can go and solve in either method. I choose to use the matrix. I'm going to honestly tell you that when I'm trying to do quick answer keys when solving systems of equations, I almost exclusively use a matrix. But again, it's your choice which one you use. I don't care. So if I do a matrix, there's my matrix, 1, 130, 10, 20, 430. And when I plug it in and I do my RREF of that matrix, I'm going to find out that the answer is 17, 13. So there are 17 $10 bills, and there are 13 $20 bills. The last problem I'm going to do in this video is number 9. It says, write a system of equations in standard form, that's the key, that has infinitely many solutions. This is how I'm going to approach the problem. First of all, I know that infinitely many solutions mean that they have the same slope and the same y-intercept. So how about I just write 2 equations that have the same slope and the same y-intercept. Now I'm going to go write those in standard form. So in standard form, it's going to be 3x plus y equals 5. But in general, we don't leave them looking like each other. We usually multiply them by something so they're a little different. So how about I multiply this equation by 2? Why did I pick 2? For no other reason than I wanted to pick some number. As long as you multiply everything in the equation by the same number, the equation is the same. So I'm not going to do anything to the first answer, but the second answer is going to become 6x plus 2y equals 10. And this would be a system of equations that has infinitely many solutions. There is no one right answer to this particular problem, just so you know. This is what I made up right now. And that's the end of the first part. I probably should have called this part 1. And in part 2, I will finish the rest of the review for the test.